This is numbers 13 and 14 on the study guide. Number 13 says a 4-inch tall rectangular brick patio has an area of 120 feet squared. Already I see a problem because the units are not the same. It says the density of the brick is 130 pounds per cubic foot. So that really means we need to be working with feet. So we're going to first start off with 4 inches and get that to feet. Since that's our starting amount, we're going to put it over 1. To get rid of inches, it's going to go in the denominator, and inches can go to feet because in 1 foot there are 12 inches. So now when we cross out our inches, the unit left is feet, which is 4/12 of a foot, or if we simplify that, it's 1/3 feet. So what we're looking at here then is to find the volume of this rectangular brick patio. That means we've got the volume of a rectangular prism. So it's going to be the area of the base times the height. Well, they already gave me the area of the base. They told me it was 120 feet squared times the height I just found. Now it's 4 inches tall, or 1/3 of a foot tall. And so basically now what you're going to do is you're going to do the 120 times 1/3, or 120 essentially divided by 3 to get 40. So that means that we have 40 feet cubed is our volume of this rectangular patio. And so now from here, we're going to change this to pounds and weight. So basically our starting amount is 40 feet cubed. We'll start it with over 1. How do I get rid of feet cubed? Well, it's going to go in the denominator. And where you can go from feet cubed to pounds, because they tell us that. They tell us that it's 130 pounds per cubic foot, or per feet cubed, so per 1 of those. So now the feet cubed will actually cancel because they're in the diagonal, and you're going to be doing 40 times 130, and what that's going to give us is 5,200 pounds of this patio. That's how much it's going to actually weigh. On number 14, it says we have a rectangular pentagonal prism with an apothem of 3 inches, and it's going to have a height of 5 inches. So then it tells us that the apothem is increased by 3 feet. Again, we're out of the wrong units. We need to make sure that we are dealing with the same unit. So I'm going to go ahead and change this feet to be inches here. So we're going to start with 3 feet over 1 times, to get rid of the feet, it's going to go in the denominator. Feet are going to go to inches here. There are 12 inches in 1 foot. Those will cancel, leaving me with 36 inches. So basically, this apothem is going to increase by 36 inches. Now I can say instead of using this, we're going to use that information. So let's figure out what the apothem is. The apothem, or the apothem, is going to actually be here this initial 3 inches, and it's now increased by 3 feet, so it's increased by 36, which means we have a total of 39 inches for our apothem. Now, we're going to look at the fact that they tell me that the height is doubled for this prism. Well, the height was 5 inches, so if we do 5 times 2, that gives me 10 inches. So now let's go ahead and start looking for the area of our base, because the volume of a regular figure is going to be the area of the base times the height of the prism. So if I start with a pentagon here and I put a circle or a dot in the middle to represent the center, and I connect these triangles to the center, that's going to make 5 triangles. That means that we're going to have 360 degrees divided among these 5 triangles to give me an angle of 72. Well, let's just go ahead and take that out. So far, this angle is 72. And I'm going to go ahead and I'm going to drop this right here. Now, this right here is called the apothem, and the apothem we found was going to be 39 inches. What I don't know is how long this is. See, I have the information for the apothem, but I'm trying to figure out the perimeter of this pentagonal prism. And so it's got 5 sides, and I really don't know what a single side length is. Well, that's where I can use some trick here. Because if I drop that apothem here, what it does is it takes that 72-degree triangle and it cuts it in half here, because it's going to cut this directly in half to give me This would be now 36. And so now that is going to be my right angle. This apothem is 39 inches, and I'm just trying to figure out this side right here. Well, if you look at the 36, this x is opposite of it, and that 39 is adjacent. So we're going to use tangent. It's going to be tangent of 36 degrees is going to equal the opposite over the adjacent. Now to get x by itself, we're going to multiply both sides by 39, so that's going to give me 39 tangent of 36 is equal to this x. And that's what we'd put in our calculator. And I'm going to get that x is about 28.3 units. However, remember, that is for this section of the triangle. That means that this is about 28.3 units. To get the whole side length, we need to double that. So if I double that, then we're looking at about 56.7, or if you just multiplied the previous answer by 2, this would be 56.6. The other one's about 56.7. That's what I'm going to go with. So this side length right here is going to be roughly, so a side is roughly 56.7 units, or 56.6 if you double this here. So I use the old answer to do this. So now from there, we've got a side length. Well, if this right here is 56.7 units, how many of those sides do I actually have? I have 5. So now we're ready to do the area of the base, which would be 1/2 times the apothem times the perimeter. So it's 1/2 times the apothem, which I found to be 39 inches, times the perimeter, which would be that 56.6 or 56.7 times how many sides? 5. And that's what I'm going to put in my calculator. So give me just a second. And I'm getting that the area of the space is about 5,528 and 25/100. That's the area of the base. So to find the volume of the new prism, it's going to be the area of the base times the height. The area of the base is 5,528 and 25/100 times how tall is this prism? I already found the height to be here to be 10. So when we multiply this by 10, I'm now going to get that this new volume is roughly 55,282.5. Let's get a unit on this. We're dealing with inches, so inches cubed would then be my final answer.